Hey everybody, this is Mr. Storm, and in this video, we are going to begin building something that's even better than what we made last time. Let's talk about what we made last time. Let's review a couple of the concepts. So first thing is, we are using the Godot game engine to learn game development. In the last video, we made our first game, which is this thing. Oh yeah. Oh, look at that. Watch out, Rockstar. There's a new game developer on the scene. Look at this. Oh, I can jump and I can move. Crazy. Okay, so not super exciting, but we learned a bunch of fundamental concepts that we're going to want to use in this next project to make something a little bit better. So let's kill all this and start from scratch. Okay, we're going to make a brand new project. Now, the thing about this, the way Godot works is each project is contained in its own little individual environment. And we can't really make a new project from Godot while it's open. So we have to kind of close everything and then start over from the beginning. So let's close Godot. And I'm going to open up the Godot launcher again. And I'm going to click create, and I'm going to write maze game because, and I'm going to put this on my flash drive again. Now the game we're going to make is called Maze Game. And the reason why it's called Maze Game is because it's a game about a maze. Amazing. All right. Click create and edit. So with the last game, there was no goal. There was no goal. There was also no way for us to lose the game. So we're going to fix those two problems with this game, with this project. Okay. So let's talk about how we're going to structure this project. In the last project, everything that we built was inside one scene. We can't do that with this project. The reason why is because we're going to have multiple levels in this game. We're going to have a level 1, level 2, level 3, level 45, however many levels you want to build. It's completely up to you. So we can't have everything all inside of one scene, right? We're also going to import artwork that we're going to use in this game to make it look a little bit nicer, okay? So we need to organize the artwork a little bit. And we're going to use multiple scripts in this game as well. So let's talk about how to organize our files a little bit. If we look at our flash drive again, let me go back down to my flash drive. We now have two project folders in my flash drive, one called First Game, one called Maze Game. First Game has all the stuff that we built. Notice that the player.gd and the game.tscn, all the things that we built in that last project, they're now in my project folder. In Maze Game, it's empty. There's nothing else other than the default stuff. But in Maze Game, we actually want to make some more folders here so that we can organize our content a little bit. So the first folder I want to make is let's call it an art folder, or we can call it sprites. So I'm going to right click on my res here, go to create new, and I'm going to click folder, and I'm going to write sprites. There we go. And we have our icon here. We can actually drag that into our sprites folder. So now we can hide it from view if we want. So the other sprites we're going to need are our super fancy graphics here. We have blue, green, and red. So we have a blue icon or a blue box for the player, a green for the goal, and a red for the enemies. We're going to grab all of these sprites here and drag them into our sprites folder. Okay. So now we can see we have blue, green, and red. All right. Let's create another folder. We'll call it scenes. And let's create another folder called scripts. Okay, this is generally the structure or the organizational structure that I use in all of my game projects. I might have more folders depending on what else I have, but generally this is how I do it. Now, one thing I want to point out, we've built these folders here in Godot, but if we were to go to our file explorer and go back to our project folders here in Maze Game, notice now we have a scenes folder, scripts folder, and a sprites folder. And if we open up sprites, we actually have, let me change the view so we can see them. We actually have those sprites here in the folder. Okay, cool. All right, all that's fancy and good. Let's start making a video game, shall we? First, we need to make a decision. This game screen might be too big for what we're trying to make. Our game is going to be nice and small, okay? So we want to change that. We also, I don't like this background color. It's a bit gross, we shall say. So I want to change the background color and I want to change the size of the screen. Luckily, we can do both of those things in the same place. Let's go to our project settings menu. In project settings, we have a ton of options we can change. The only ones I really care about are changing the size of the screen and changing the background color. So let's do the screen first. So if we go to display and then window, we can change viewport width and viewport height. So if I go to viewport width, notice that it's 1152 by 648. That's too big. I'm going to make it 600 by 400. Make it a lot smaller. Okay. I also want to change it so that whenever we expand our window, it'll grow everything and it will make everything stretch to fit the viewport. So I'm going to go to mode and click viewport. Okay. Now the other option is that background color. Now we can change that in rendering. If we go to environment, we have this default clear color. I'm going to choose like an orange, like a light orange, because I think like almost like a tan. I think that'll look kind of nice with the other colors of my objects. I'm going to click close. Okay, perfect. So now my screen is much smaller and I have that nice orange or yellowish orange that's there. Okay, perfect. So now we can start building our first scene. Let's make level 1. So I'm going to click 2D scene and I'm going to rename it to level 1. And I'm going to save it. So go to scene, save scene. Now, instead of just saving it right here in my res folder, I want to save it in my scenes folder. So now I can organize my scenes in that scenes folder. Beautiful. Okay. So now we need to create the player. So this player object is going to exist in all of my levels. And it is going to be able to do the same thing in all of my levels. So we have two options. We can either build our player in this level like we did last time, but then when we create a next level, our level 2, we'll have to build the player all over again for player 2 or for level 2. And then in level 3, we'll have to build the player all over again, and so on and so forth. And so every level we build is almost like building a brand new game from scratch every time. We don't want that. What we want to do instead is create a scene, a completely empty scene, and build our player in that. And then what we can do is we can load that scene into any of the scenes in our game so that we only have to build the player once, and then we import that player into any scene that we want. So at this point, even though we've just created the scene and we haven't put anything in it yet, we're going to make a completely new scene. I'm going to click the plus icon here to create a new scene. And now in this scene, I want my root node to be character body 2D. So I'm going to click other node and I'm going to look for character body 2D. And I'm going to rename this node to player. Okay. Now in this player node or in this player scene now, we need to add the things to make this error go away. We need a sprite renderer. We need a character, or we need a collision shape. We need a script to tell it how to behave. So let's build those things. First, let's add our sprite renderer. So I'm going to click this plus button and go to sprite 2D. And for my texture, I'm going to choose my blue texture and drag it over. Oh my gosh, look how big that thing is. That is way too big for what we want. Our screen is right here and our sprite takes up way more of the screen, like covers the whole thing and then some. So let's talk about transform properties. So over here in our inspector, we have our texture, we have all this other stuff. Down here, under the Node 2D option, we have something called transform. Transform gives us some options. The position of our shape, which, by the way, needs to stay at 0, 0. Player also needs to stay at 0, 0. Okay, don't move it. But here we have position, we have rotation, meaning we can rotate this shape. Okay, I'm going to go back to 0 there. And we have scale. Scale is what we're looking for. Scale is the size of something. So I'm going to change this to something way smaller than it is. Right now, this is its original scale, so it's at 1. I need a much smaller number than 1. I'm going to say 0.01 and see how far that gets us. Okay. All right. You know what? That's not too bad, actually. That's a pretty decent size. Let's say 0.03. That's a little better. Okay, I like that a little better. All right. Now, at this point, you're probably tempted to grab this thing and move it all over here because we want to be able to see it. We don't want it up in the corner. The problem with that is, remember that this is its own scene. When we import the scene into another scene, it's going to treat this point here as the middle of the scene. So if we import this into another scene, then instead of our player being at the middle where it's supposed to be, it's going to be over and to the right, right? Or it's going to be to the right and down. It's not going to be in the right. So the middle of this is not going to be in the middle of the shape. It's going to be it's going to be over here, right? We don't want that. So again, don't move your stuff around in these individual scenes, right? This is the center. This is where it is. Okay, that's the center. All right. Okay, so the scale looks pretty good. We need a collision shape. So let's add a collision shape here. Collision shape 2D. And let's add a nice rectangle shape to my collider. Oh, there we go. Okay, perfect. Now, if you can see, some of it's not pixel perfect. And the reason why is because this shape isn't exactly pixel perfect either. So just try to make it as uniform as you can. Okay, so we have a collider, we have artwork, now we need a script. We need to learn how to write some code. I know, we were avoiding it as much as we possibly could, but we need to learn how to write some code. But tell you what, before we do that, let's put this into our scene and see what it looks like. All right, we need to save this scene. Let's go scene, save scene, and it's in the scenes folder. Yep, player. Okay, good. So now we have player and level 1. All right, let's go back to our level 1. Let's put a copy of our player into level 1. Now, there are quite a few ways to do this. We could click this link button and find the node we want, or find the scene we want, and then instantiate it that way. Or we can just drag it out. I'm just going to drag it out. So now we have a player in our scene. Let's go ahead and click play. And let's select current. Perfect. Beautiful. It doesn't do anything yet, but it's there. It exists. Okay. The nice thing is, now that we have player over here inside level 1, it's exactly, or it's a perfect copy of this player scene. So when we make changes to this player scene, those changes will automatically be applied to this player itself. And we can see that it is a scene by looking at this icon. Okay. All right. Perfect. So now we need to write some code. All right. We've procrastinated long enough. Let's actually learn how to write some code. To attach a script, we're going to do the same thing we did last time. We're going to click plus script. But we are going to turn off the template. Dun, dun, dun. Yeah, we're going to turn it off. Okay, because we don't want all that extra code in there. We're going to write our own. And click create. Okay, so what we have here is we have an empty script except for line 1. Let me explain what line 1 is doing. I'm going to zoom in a bit so we can see. Line 1 says extends character body 2D. What that means is this object that the script is attached to, this node is a character body 2D node. Now, character body has a bunch of code already embedded into the node. It has things like gravity. It has things like velocity. It has things like angular momentum, a bunch of physical properties that already exist, right? So we want all of those things so that we can actually move our player around in a way that, you know, the game engine can understand. If we deleted this, then a lot of the code we try to write will not work. So do not touch line 1. That's the number one rule for programming in Godot. Don't ever touch line 1 unless you know absolutely what you're doing. Okay? Take a sip of my soda here real quick. Okay, so let's actually start writing some code. So if you've ever programmed before, ever done any programming before, this is going to be a bit of a review. But for those of you who are just watching this video or this series for the first time, I'm going to assume you don't know anything about programming. Okay, so we're going to take it slow. First of all, Godot uses a programming language called GDScript. GDScript works a lot like Python. There are some things that are different. There are a lot of things that are similar. So if you've ever programmed in Python, then you're going to understand some of these concepts. But again, you don't have to know any programming at all. All right. Okay, let's talk about how scripts work. Scripts, in most programming languages, are read from top to bottom, left to right. It's the same thing in GDScript. So the thing that's on line 1 is going to happen before the thing on line 2, and the thing on line 2 is going to happen before the thing on line 3. Now, we can skip lines like we have here. That's totally fine. GDScript is okay with you skipping lines. It will just punch something. Sorry. I'm gesticulating. You can't see because my camera's off, but I'm getting excited about programming and I'm waving my arms wildly. Anyway, GDScript ignores what we call white space, so extra lines. So you can add in extra lines all you want just to make it a little easier for you to read your code. Okay. Now, when a script is run, it needs something called a function to tell the program. I just got a message somewhere. I don't know. Anyway, so it needs something called a function to tell the program what to do and when. So GDScript has a couple of different functions that it recognizes by default. One of those functions is called the process function. The process function will run whatever code is inside of that function every frame of the game. So we're going to access the process function for this script because everything in this script, we want it to happen every frame of the game. Okay. So to create the process function, we need to type the keyword func, F-U-N-C, not funk like F-U-N-K, like the music genre, but F-U-N-C, func. Then after that, we're going to type a space, and then we need to find the function by its name. Now, because this is a function that GDScript already recognizes, all we have to do is type underscore and then start typing the name of the function. So I'm going to zoom out. Actually, let me go full screen so we can see. So I've just typed underscore PR and it found process delta float void, found all of this. I can use the arrow keys to scroll through, but once I find the thing I want, I can hit tab and it will finish writing all of that for me. So what does this mean? Well, this means we're calling a function, we're defining a function. The function we're defining is the process function. The process function has these open and close parentheses. All functions have open and close parentheses. And inside these parentheses, we have something called delta float. Delta is a shortcut for time. It's the amount of time that has passed since the last frame. We're going to talk a lot about delta later on. Don't worry about it because we're not going to need it for this video, but delta is a thing we're going to use a lot in game development. And then we have void. Again, we don't need to talk about that because we'll talk about it at another time. All you need to know is func process. So this is the process function. And what the process function does is it runs every frame of the game. Now, what I've just done is I've added what's called a comment. If you type a pound sign, whatever you type after the pound sign is just basically text that you can put in your script. The compiler will completely ignore this text here. Okay. Now, why is this line red? Well, this line is red because there's an error. The error is it says expected indented block after function declaration. So it's saying we've written a function, but we need to have something inside this function in order for it to actually work. So by inside, I mean it has to be underneath and it has to be indented by 1. So notice that my cursor isn't all the way at the end here. It's now indented, or there's some space between the edge and where my cursor is. That is how we indicate that something it belongs to this function, right? So what we want to do is a little bit more complicated than what I want to explain right now. First, let's just get this function working. So let's print something into our console. So I'm going to type print, and I'm going to type poo-poo pp. Okay? Very mature, I know. What this is going to do is at every frame of the game, it's going to print poo-poo pp to my output down here. Okay? So let's save and let's play. So the square can't move, but notice down here, it says poo poo pee pee, and it's saying it over and over again. Look at how many messages we're getting. Oh my gosh, because we're running this game at 60 frames per second. And so for every second, we're getting another 60 messages that say poo poo pee pee. All right. So that's how the process function works. Every frame of the game, it's printing poo poo pee pee. All right. So let's stop that. Come on, grow up, guys. Jeez. All right. Get rid of that. Immature. Okay, so what do we actually want to do? Well, we want to check to see if we're pushing a key on the keyboard. If we are pressing a key on the keyboard, we want something to happen, depending on the key that we're pressing. In order to recognize keys in the keyboard, though, we need to define which keys we want to actually be tied to specific things. So we're actually going to go back to our project menu up here. We're going to go to project settings. And let's talk about the input map. So go to the input map tab here. Now in the input map, this is where we can define custom inputs that our game can recognize. So let's start with the directional keys first. And as a matter of fact, let's just start with going to the right. Easy to do, right? So I want my movement in this game to be defined by the WASD keys. W up, A to the left, S down, D to the right. So in here, under add new action, I'm going to type right and hit enter. So now we've created a new action called right. And in order to tell it that right is going to be associated with the D key, we need to hit this plus button right here. And we need to hit D on the keyboard and click OK. So now right is tied to the D key. So anytime I hit D on the keyboard, it's going to call this action right. So inside my script, I need to check to see if we're pressing the D key. So what we can do is we can use something called an if statement. If statements are in every programming language. It allows us to check a condition, right? So if now we need to access input, because this is our input map, we need to access something called input. So I'm going to type input in all capital letters, dot is action pressed. And the action I'm looking for is right. So input meaning is there some kind of input coming into my game, either from a video game controller, the keyboard, the mouse, whatever. Dot is action pressed. Is action pressed is a function. So we're calling a function called is action pressed. And the action we're looking for is the write action. So all this is saying is if we're pressing the D key, then we do something. We need a colon at the end of this if statement, and we need to press enter. Now notice that my cursor is now indented twice. That's because not only is this code inside my if statement, but it's also inside the function as well. So it's indented twice. All right, so in here, all we want to do is we want to move on the X axis to the right whenever we're pushing the D key. So let's say move local X. We want to move by 1. So while we're pressing that key, we want to move by 1. All right, let's save everything and let's play. Look at that. It's happening. It doesn't do anything else. It just keeps going to the, and it's eventually going to be gone, but it's happening. It's working. It did something. Okay. That was way too exciting. All right. I need to calm down from that. Whew. Well, there's a problem. There's a couple problems. One problem is it only moves in one direction. So let's see if we can make it go to the left. Well, first, we need a new input. So let's go back to our input map and let's create a new input called left. And let's tie our left movement to the A key. Okay, so now we want to check to see if our input is left. It needs to be inside this function, but it needs to be on the same level as this if statement, because we don't want it to happen inside this if statement. We want it to happen outside this if statement. So we want this to check first, then our new thing. So we need to indent once, just once. And now we can type if input.is action pressed left, and we want to move our local X, but if we move by 1, then we're just going to be going to the right again. So how do we go to the left? If the right is positive, then the left is probably negative. So let's try -1 and see if that works. Let's play our game. So we can move to the right, and now we can move back to the left. Okay. All right, now we're cooking with gas. We can now move left and right. Beautiful. How about up and down? Surely it's got to be just as easy, right? Okay, let's see. We need inputs for that, so let's create an input for up and an input for down. Our up input is going to be W, and our down input is going to be S. Okay, easy enough. And you know what? We can, if input is action pressed, let's do, oh, where's up? There it is, up. Now, instead of move local X, it's probably going to be move local Y, because we want to move on the Y axis, because the Y axis is vertical, right? So move local Y. Okay. Up is probably going to be positive. Let's 1. All right. Let's do down while we're here. So actually we can just copy and paste. Let's just do that. Okay. And let's change this to down. Okay. And let's change that to -1. Okay. All right. Ooh, this might actually work. Let's try it. So I can go right. I can go left. Let's try pushing up. Whoa, hold on. Whoa. Wait. Hold on. Okay, let's try down. No. Oh my gosh, they're backward. Why? Why are they backward? Well, don't freak out. Let's talk about it. They're backward because The way Godot treats the X and Y axis, let's zoom in here. The way it treats the X and Y axis can be shown on this ruler. Now, it's probably really hard to see because, you know, the video is probably not big enough. But if we track the X axis, we can see that if we go from 0 on the X to the right, we're going in a positive direction. 50, 100, 150, 200, 250, so on. If we go from 0 to the left, we're going in a negative direction, negative 50, negative 100, negative 150, negative 200. Okay, that makes sense. And our code's working the way it's supposed to based on that principle. But going up and down, it's not that way. Going up and down, starting 0, if we're going up, notice that we're actually going in a negative direction. So going up in Godot is negative. So negative 50, negative 100. And going down is positive. It's the opposite of what we intuit it to be, right? So it's the exact opposite. So how do we fix that though? Well, in our scripts, all we have to do is change our up to a negative, change our down to a positive. That's it. And now we have full movement. But it's boring though. It's really boring actually. It's really slow. So how do we fix that? Well, we're saying we want to move 1 pixel per frame. That might be too slow. Maybe 10 would be better. So we can come in here and change all of these to 10, but there's actually a smarter way to do that. When we have all these values, we can actually put this in something called a variable. So in programming, a variable is a place where we can store some values, and then whenever we want to call that value or use that value, we just call the name of the variable. It's handy in situations like this where we're going to use that value a bunch of times, but we don't want to, type it a bunch of times. So what we can do is we can just change the value once at the variable, and it will change it for all of these as well. So to create a new variable, we're going to type the keyword var. Then we're going to give it a name. Just like with the function, we have to give it a name. For this, let's call it speed. And let's set it to, 10. So now anywhere we typed 1, we can actually just replace it with speed. So that'll be 10. That's negative 10. Same thing here, negative 10. Positive 10. Okay, so now when we play our game, ooh, we're going, whoa, that's way too fast. Oh man, 10 was way too much. But luckily, we created it as a variable. So now we don't have to change all of these anymore. We can just change it here. Let's try 5. That might be better. Let's try it. Much more reasonable. Okay, so 5 feels a whole lot better. Okay, wow, we did a lot. We did a lot. Look, we wrote our first custom script. We learned a lot about programming. We've organized our files a bit. We created a scene to store our game, and we created a scene for our player, and we put our player into our level 1 scene. Wow, we did quite a bit in this video. So in the next video, let's turn this into an actual video game, shall we? All right, I'll see you there.